Hey guys, today we're going to be talking about the big 5 dplyr functions in R and RStudio for data analysis. You can use these 5 essential functions to do nearly 80% of data analysis tasks. Today, I'm going to provide easy memory tricks to remember these and an overview with real examples of how to implement these 5 functions. Let's get started. So what is dplyr? Some people say dplyr, which is fine, but it stands actually for data frame PLIER. Now, a PLIER is a general purpose tool that we can use for physical projects like building or crafting. So dplyr is meant to be a virtual version of this for your data and data analysis needs. It's part of tidyverse. Tidyverse is a universe or ecosystem of R packages for working with data. You can consider dplyr to be the cornerstone essential package in this universe. On the right-hand side here, I have my RStudio that I'm going to help you walk through everything. On the left-hand side, we have these notes that we're going to follow along that already has some results from R code kind of embedded in it. In case anyone's wondering, this is an example of R markdown.rmd file. Okay, so the first thing we want to do is we need to load our package. So I'm going to run it over here, and you can see down in the console, we have the result. So it just loads tidyverse. I've already done this, so we don't see any more output, but on the left-hand side, this is what originally would show once you run library tidyverse. What you can see is it's attaching core tidyverse packages, including dplyr, but also readr, string R, per, ggplot2, and so forth. So again, tidyverse is an ecosystem of R packages. Now, next up, we want to go ahead and load a CSV, a little data set that I made for this. You can see when we run that, as shown on the left and on the right, that we have 2 columns that are character, 3 columns that are doubles here. So 8 rows, rows go across the screen, columns go down a screen, 8 rows, 5 columns. 2 of those columns are character columns, that's species and status. That means there's letters, characters that are in strings and quotes. The other 3 columns are doubles. Doubles are a type of number, so that's going to be tree ID, dBH, centimeter, height, meters. So let's actually look at this data and see what we have. All right, so again, we see that it's a tibble. A tibble is a special type of data frame that is from the tidyverse ecosystem of packages. It's 8 rows, 5 columns. Like I said, you always put row number first, X, then column number. Now you can see that we have all our different columns, and you can see the type of each one, a double, a character, a double, another double, and finally a character. So one row here is exactly one tree. So for example, the first row, that's tree ID 1, it's an oak, it has a dBH of 25 centimeters, a height of 12 meters, and it's live as opposed to dead. Let's keep going, and let's talk about the big 5 dplyr functions. So those are filter, select, mutate, summarize, and group by. What's great about these things is they're verbs, they're action words. So we filter to pick rows to keep. Note, filter as an R, R for rows, versus select to pick columns that we want to keep. Select has a C, C for columns. So filter for rows, select for columns. Then we mutate to either add a new column or modify an existing one. We summarize to calculate statistics. And finally, group by. Group by is a way to group or bin data into categories. You usually use it followed by a summarize. So group by, and then that goes to a summarize. All right, so let's see these in action. Let's say we want to see just the rows that are oak trees. Now, I noticed just earlier that I had actually made a mistake here. I wanted to show you guys, see if you would catch my R code. You can see here, this is about keeping the columns, which is actually what the next step's going to be. So we want to change this, and we want to say, keep only rows that have species value oak. All right, so then instead of the select here, we're going to say filter, and we want to filter our trees data so that we just keep things where species has a value oak. Note, in code, when you see a double equal sign, translate that to a question saying is comparable to. So what we're doing is we're checking that we want all the rows where the species column is comparable to the value oak. So let's actually run this now, and we see what we get, a tibble 3 by 5. So 3 rows, each of them are where species is oak. So that's exactly what we wanted. Great. All right, so moving forward now, show me the columns that are species and height. So just those columns. So to do that, we're gonna say, go ahead and run this. We use select and we select species, comma, height M. So if we wanted to add some additional things here, we could just put on another comma and add a third argument, status. Rerun this and you see we get status as well. We can go ahead and delete that because we just want these two. So we have 8 by 2, we have every row, but we only have the column species and height M. All right, so then we keep going. So now let's add a new column called size. That's gonna have a value tall if the height is greater than 15, or if not, then it'll have a value short. So we're gonna use mutate for this. So mutate mutate is to change columns, either to add new ones or modify existing ones. So here we're gonna add a new column called size. So we mutate, make a size column, which is gonna have a value. When you have one equal sign, translate that to is assigned value, so forth. So this is saying the size column is assigned value, whatever the result of this if else is gonna be. So in if else, we're saying if the height column is greater than 15, then we get the value tall, else we get the value short. So if this condition, then return the second argument, else return the third argument. All right, so go ahead and run that. And now you can see that we get a tibble that's 8 by 6 now. It's all the same data, except now we have a size column at the end, another character column. So you can see that it's short when the height is less than 15. It's tall when it's greater than 15. Or let me actually rephrase that. Specifically, we're checking if the height is greater than 15, then it's tall, which means that, as you can see here, when the height was 15, that's short because it's not greater than 15. All right, so now let's calculate the average height. So we're gonna do some statistics. So this is where summarize comes in. So let's say we wanna calculate the average height of all the trees. We can say trees, then we call summarize, and again, we're gonna make a new column actually called average height, is assigned value, mean of height. We run that, and you see we get this tibble of 1 by 1, average height, which was the column that we just made, and that's 15.4. But what if we want to actually do two calculations at the same time? So instead of just calculating average height, what if we wanted average height and the average DBH? So with summarize, you can just comma separate these different calculations that you want to perform. So let's run this one, and you can see now it's a tibble that's 1 by 2, because we have average DBH and average height. So the two statistics there. Next, we're going to just combine this idea of summarize, but first we're going to group the data by species. So in other words, you look at the data up here, we want to take just the oaks, for example, there's 3 of them, and we want to calculate the average height of just oaks, and we want to get the number of them. In other words, like I said, there's 3 of them, so the count would be 3. Versus pine, where there's 1, 2, 3 as well, but then maple, there's just 2. All right, so let's run this one. So you can see what we get, a 3 by 3 tibble. So we have a row for each species, maple, oak, pine. You can see the right-hand column count. We have 2, 3, 3. And we have an average height that's specific to each category of data. So this is where you group by, and then that goes into a summarize. So we've been using this fancy little symbol, this % sign greater than % sign. Now in R, that means a pipe. There's different ways to actually make the pipe symbol, but this is the most common. So you can interpret the pipe as meaning then, T-H-E-N, then. So in other words, when you see this, we're saying take trees, the tibble, then apply group by, that function, and you group by species, then apply the summarize function and get the average, DBH, and calculating the mean and also the count here. So take the trees tibble, then apply the group by function, then apply the summarize function. Tidyverse and dplyr are really nice in this way, where you can read out what the code's doing in a very logical step-by-step way, which is part of the reason they're probably the most popular packages in R. All right, guys, so today, to recap, we talked about the big 5 dplyr functions. We have filter to keep certain rows, select to keep certain columns, mutate to create new or modify existing columns, summarize to calculate statistics, and then group by followed by summarize in order to get categories of data and then calculate statistics per category. Hope you guys enjoyed this video. If you want the R file or the .rmd file I used today, comment data PLIER below. And don't forget to like and subscribe for more R, Python, and data science tutorials. Hope you guys have a great day.